Just a minute. Some slight problem in the network here. Is the voice clear? Network problem I have to overcome. Is voice clear? Okay. Now, 1 minute. For a little time I cannot chat because small reason. This mobile has got a problem. Sometime you have to reboot it and start. Okay. I'll just switch off and then again start. But class will run. No problem. I think I have to change this one. It's a problem only. 1 minute. I cannot chat for a few minutes now. I will write something. You just understand. Again, same problem. See. One small information. Last time in bending stress part, I asked some question regarding RCC part. That is, in basic bending theory, we use M by I equal to sigma by Y. Sigma means stress, because in the strength of materials, I take stress as sigma. But RCC I cannot take sigma because sigma in working stress method stands for permissible stress. So there I will take F. So I will put M by I equal to F by Y today. And I think this rain is waiting for me to start the class, I think. So many times it happens. When I start with important theory, see, slight disturbance there. Okay, I will manage. Now, see, I will write here now. I don't know how much space I can write here. See, basic bending theory. Basic bending theory is M by I equal to, I wrote sigma by Y. Sometime instead of sigma, you can tell F also. See, RCC I cannot use sigma. There's a reason I will tell you later. So you can use F, or if you use F, the theory will be M by I equal to F by Y. M is the bending moment for the cross section. I is moment of inertia of cross section about neutral axis. Then sigma or F, they are bending stress at Y from neutral axis. Now, if the bending is sagging, top tension, bottom compression, somewhere neutral layer is there. If I draw across the cross section, neutral axis will come. Stress diagram will come like this. This is compression, this is tension, this is F1 I wrote earlier, I wrote F2 here. These are the maximum stresses. Or if bending moment is hogging in nature, top tension, bottom compression, the stress diagram will be like this. This is tension, compression, same F1, F2. Here F1 is compression, F2 is tension. Here F1 is tension, F2 is compression. This all told, but I derived and stopped there. I did not go elaborately because I told you better go for this class is mainly for practical purpose, not for academic purpose, but learning purpose. I immediately asked a question for one question I solved where I found internal resisting forces. The resisting couple came equal to bending moment, perfectly tallied. I explained correctly how bending moment is resisted by the cross section. 1 minute. I hope at least now it will open. Because unless it opens, problem. Okay, 1 minute. How bending stresses are resisted by cross section, I explained thoroughly in the class. Then last class, I asked a question, somewhat some people call brain teaser or etc. In the basic bending theory, in strength of materials, you use M by I equal to F by Y. I is moment of inertia. But in RCC, if you remember, we don't consider moment of inertia there. We go for some other approach. There you see, here if you write equation for M, what will happen? If I write equation for M here, it will become I divided by Y into F I will write, because by today's class, because of RCC, I am taking F or sigma over. But you don't write that way. Some people tell, sir, there is no denominator, sir, there is only formula. What formula? I will tell the formula, because not by hearted, RCC I can see it. At least now I can hope that everything is okay. 1 minute. Yes, everything is okay. Okay now. How much? Now I can decide how much I can write also, because I want to know the restriction first. 1 minute. Up to 1 minute. See, partially not visible. I will slightly turn the screen now. I wrote upper side basic bending theory. It is not visible. I will make it visible now. Okay. I will make it visible. See, these are all now only for few more days, because someone is coming who will put an app in app. He will put an app here, and the class he will tell how to use the app and take the class without this focusing all. Before the class only I can set everything and give a display there. Then no more setting. He told he will tell another 3-4 days. 1 minute. I slightly rotate now. I want to know everything visible. Yes. Okay. Only few days more. Okay. That is even for Zoom class also. He told use an app. It is very useful. Okay, now I wrote basic bending theory. I asked a question there. See, I will write the equation. In RCC, you don't write like this. You write, see why I am telling, because this class purpose is not academic. I told already. This is not a class for those who want to pass exam. You study all this one, you will fail in exam. Because by confusion after confusion, that all will come after this basic part is over. I will go systematically, I will explain this equation furthermore, section modulus, everything will come in a correct order. People who are interested in academic, study from there. You don't see this one. Okay, now see. RCC equation is, I will write here now, because I don't have to by heart it. I will equate the moment of the compression area to tension area. My equation will come Bx into x by 2. Bx square by 2 equal to m times AST into d minus x. This will give equation for neutral axis. Okay, then remember, this is nothing but a1y1 plus a2y2 or taking moment, same theory. Usually you take moment about the edge. Here you take moment about neutral axis. If you take moment about the neutral axis, moment of compression area should be equal to moment of tension area. And remember, this is not RCC class. Too much I can't tell. And then, if you got the stress distribution diagram, this I will call FC, stress in concrete maximum stress in concrete in compression. This is stress in steel in tension. Okay. Then the relation is, this is neutral axis depth x, this is d. This relation here, what? M times FCC divided by FST equal to x divided by d minus x. This is the, actually in the RCC I wrote FCC I have not written. Today I am writing by FCC. Stress in concrete in compression, stress in steel in tension. There only FC I wrote. So MFC by FST equal to x divided by d minus x. And then equation for M, we don't use I by Y format. One equation is by considering compression force into lever arm. That equation is Bx FCC by 2 into D minus x by 3. Or if you take M equation based on tension, the answer is M equal to AST into FST into D minus x by 3. Tell me, those who studied RCC, do you remember all this fast? Otherwise, believe me, none of this is by hearted. I can see everything there. None of this is by hearted. First of all, I am so weak in by hearting. I will see a value when you type something. I will see there. Then come here. I will ask how much it is. Once again, I have to go and see there. Okay. This is principle. Now see. What I will do is slowly I will link them. I asked a question then last time. Only one person answered in the YouTube. Good. Any question I raise in YouTube, answer should be given in the YouTube, not personal number. Nobody answered. A person known to me, he answered. I told, no, wrong. But I got some 4-5 answer to my personal number. All unknown people. I don't want to tell what they told. Of course, nothing damaging or that way. But one of them raised a question. It looks, this question has no answer. RCC we do that way. Then I did not reply to him. I just replied. Don't question me in personal number. Anything you require, question in YouTube. There I will answer. So I will just do one thing. If you give some answer, if wrong, I will tell wrong. Why me? Suppose question will come. Why? Why means I am only telling correct or wrong. So question was, in bending theory, moment of inertia used. But in RC theory, moment of inertia is not used. Correct. They will tell. See, no divide. See, Mi by y into F. Actually, remember, this I by y in strength of materials, it is called what? Tell me, if you remember. I will go slowly. This I by y, there is a name. Anybody know it? I by y has got a name. Anybody know it? It has got a name. Yes, it is called section modulus. I will come to it. Z or section modulus. I will come to it. See, right now briefly, once this RC theory linking is over, I will tell you, today I am starting basic bending theory in perfect order, but one thing, derivation already over. Derivation don't ask me. Derivation I have done very neatly. So therefore, those who are academic or want to know more systematically, from there you refer. This is for knowledge purpose. See, now, my question was, in bending theory, you use moment of inertia I. But in RC, you are not using moment of inertia I. Yes or no? In my offline class, if I ask in the classroom, they will tell yes. Then I will tell them, no, I am using moment of inertia here. They will tell, Yelli sir, when moment of inertia is there, cube will come. Someone told, sir, a cube will come. What will come? Cube will come. It came here. Sir, where sir? It came here. Abba, they will tell, I cannot see. You cannot see. But I can see. Not this way. I can see from the inner mind. See, if I look there, I can see moment of inertia crystal clear there. My question was, all the people who think they know basic concept, answer it now. Tell me, where is moment of inertia here? This question I asked you last time, correct? Now, to further help them, and also for people who are studying both subjects, and this class, remember, is for basic structural knowledge. So I am doing for the sake of what? People who are in the group. Others, they will get benefit. Others, they are getting benefit for this chapter. 1 minute. Now, I will go to an example of RC. Okay. Rubbing paper I don't get. Okay, right here. I will go to an example now, and once I will solve by RC basic bending theory, then I will solve by RC theory, then I will show you where moment of inertia is there in RCC. Okay? I will show you where moment of inertia is in RCC. Clear? I will show where moment of inertia is in RCC. Got it? I will show where moment of inertia is there in RCC. But that is not the answer to my question. You show me where. In the equation where. Where means, sir, there you wrote, but here not visible. I will tell, here also visible. That is the question. So, question will continue now. Open for anybody who is in the structural engineering field. If somebody answers, non-stop I will give, don't worry. Because of lot of commitment, I could not upload those class of brain teasers. Once I start, see how much it will come. Those who came to my class, you know how much brain teaser I ask. Okay, now, time being, leave it. I will take an example here. See, consider, just 1 minute, I should first see that board is visible. This is a matter of only few more days. It's visible. Consider cross-section of a RC beam, of a RC means reinforced concrete beam, say beam, 200 millimeter wide by anything will do, say 600 millimeter deep. Okay, over. With tension reinforcement, tension Ri, in the form of 4 bars of 20 tor beta, it will become more reinforced. Okay. Some will ask, how you know it? Don't ask how I know it. 4 number of 16 mm diameter. I want a tor mild. 4 bars of 16 mm diameter. Okay. Then at effective cover, I will tell you what is effective cover. Effective cover of 40 clear plus 10 etc. 50 millimeter, round number, over. Then cross section is subjected to, remember, this is working stress method. Limit state method we cannot do because it is beyond elastic limit. Our question is for working stress method. Actually very powerful method. Subjected to sagging BM or BM of ಎಷ್ಟು ಆಗುತ್ತೆ? I think this beam, it can resist a bending moment of around 55, 56. M20, if I take M20 concrete and Fe415 steel, it can have a moment of resistance of around 60, 70 kilonewton meter. A beam, don't worry, I will apply lesser bending moment of 50 kilonewton meter. Again, some will wonder, how you know it? How I know it? If I go to a hotel, idli how much cost, dosa how much cost, I get a feeling. Same way it is. 50 kilonewton meter sagging BM. Remember, bottom tension, top compression, over. Now, question is, find maximum compressive stress in concrete, compressive stress developed in concrete, and tensile stress. This pen is not writing. Stress developed in steel, due to given BM, Now, small problem. If required, I will put the ink. Okay, I'll check it. Due to given BM. Further, remember, make a note. This is a composite section where materials are, 2 different materials are there. If composite section is there, you should solve the question based on equivalent area. Therefore, anybody can tell what we require. In case of composite section, we require conversion. Tell me, what you require? One term you require. I will give that value directly now. One term will require. Anybody can tell what is required for a composite section? First, what is required? Modular ratio, correct. So I will give here, take modular ratio, our symbol is M, equal to, just imagine it is M20 concrete. Those who want. Today I am giving directly. If it is M20 concrete, RCC, you know that it will come 13.33. Okay, take it over. This is the question. Remember, I will solve by strength of materials approach without knowing RCC, and RC equation knowing RCC part. Okay, now first someone commented there, known person, he told in RCC permissible stress is given, therefore accounted there. I told the answer to him, you are nowhere near the answer. Very sorry for him. He's a known person, very hardworking. He tried it. I won't tell the name, you can see there. My answer was nowhere near. No. Therefore, see, today I am not giving you permissible stress first of all. Where is permissible stress? Where is IS code? Nothing is here. See, this question I am not used IS code. So nobody can tell IS code adjusted. IS code is not there. See, my IS code is here. This is the IS code. I will do one thing. I won't throw, go. I don't want you today. Over. Start. Now, first I will put cross section. See, cross section. All dimensions in millimeter. See, I will do as per first I will do one thing. I will put the cross section. This width is 200 millimeter. Overall depth is 600. They told in the question 600. There are 4 bars of 16 mm diameter. 4 of 16 mm diameter. There is a effective cover of 50 millimeter. So anybody can tell me what is this distance. This is given in the question. Effective cover means from the extreme tension edge to center of steel. So many classes online I am telling, they will tell effective cover is from the bottommost edge. No, you should not tell top bottom. If it is hogging beam, so telling distance X is from the top and all are wrong concept. You tell X is from the compression edge and effective cover is from the tension edge. That will take care. See, our cross section is subjected to sagging beam. So bottom tension, top compression. Okay, now this will be equal to why unnecessary 550 millimeter. Correct? Anybody can tell me what is the name for this one? Anybody can tell me what is the name for this one? 58. N 58. What is 58? 58 no. Name is effective depth. No. Today we are not knowing effective depth. Why? I am not in RCC. I am in strength of materials. This is just distance from here to steel. Okay. Now, use basic bending theory. Abba. Basic bending theory. That is, in general, M by I equal to F by Y. Oh. This Y is not vertical Y, it is distance. Today there is no X, etc. Somehow this rain is targeting me. It is telling, you are telling a principle and I want to disturb you. Okay, now, over. Do not, now, very, very important. In RCC, see, here concrete in tension side is completely ignored. Do you know it? In RCC, concrete in tension side is completely ignored. Heard of it? Yes or no? Concrete in tension side is completely ignored. Right. So right here, concrete, you write here, concrete in tension zone is completely ignored. And also, one of the material is concrete, other is steel. You should consider what? Cross section or in terms of either equivalent concrete or equivalent steel area. Equivalent steel. Your choice. You can do whatever you want. But we will consider in terms of equivalent. Tell what? Usually no, in my class or everywhere throughout the world, they consider in terms of equivalent. What? In terms of equivalent. Past. We consider usually in all, everywhere in the world, they consider in terms of equivalent. Equivalent what? Equivalent area in terms of either concrete or steel. No. Equivalent, correct. In terms of either concrete or steel. Which one? You know the answer. RCC. Concrete. So we consider in terms of concrete. Then there is a condition. Remember, condition is area conversion. Area conversion. That is what? Steel area converted to, see now, converted to equivalent concrete area. Tell what you have to do. Then if you are converting steel area into equivalent concrete area, tell what you have to do. Multiply by M or divide by M. See, furthermore RCC I cannot tell. People who are listening now are understood that they know RCC. Multiply by M. See, steel is stronger, concrete weaker. You remove the steel, in that place bring concrete. You have to multiply by M. Remember, M. And also, whatever is the stress in steel, see, whatever stress in steel, you want to convert into, or once you get stress in concrete, once we get stress for equivalent concrete, then actual stress for steel is what? Tell me. Multiply by M or divide by M. Multiply by M or divide by M. Actual stress for, no, not divide. Yeah, no. Be careful. I am trying to trap. That is, in RCC what you do is, you write stress in steel FST. I want to convert steel stress to concrete. Then you divide by M. Here not that way. We get stress in concrete. Then to convert to steel, what do you have to do? Not divide. No. These are all called elementary doubts. In RCC, I will go to RCC later. In RCC, what you do is, FST is the stress in steel. We want equivalent for concrete, we divide by M. But here, whatever stress comes in concrete, what you are doing? We want then what stress will come in steel. Steel will get more stress. It is again multiply by M. Okay. See, RCC what you do is, steel area we convert to concrete. Multiply by M. Stress in steel we convert to stress in concrete. Divide by M. Here not that way. Concrete answer comes. Come back to steel. Multiply by M. Okay. If this is not clear, it is RCC problem. Clear? Fast. You tell me clear, I will start. You tell clear, I will start. Solution. Actually, I am risking now. If answer is not telling, I will lose my complete face. People will start laughing. And some will tell, sir, delete the video. I will not delete the video. I will face the consequences. Lifetime, I should be struggling then. Oh, I made a mistake like that. Okay, now, see, all I will remove now, I will put equivalent concrete section now. See, this I will remove. So, now I will do one thing now. I will write equivalent concrete cross section. Concrete cross section. Or you can write cross section in terms of equivalent concrete is, see, one thing forgotten, somewhere here they will be neutral axis. I forgot to tell you. Somewhere here they will be neutral axis. See, there will be neutral axis. Okay. Somewhere here, no x. So, upper side is in compression. This is in tension. This is ignored. Therefore, there is compression area here of 200 width and depth. I don't know. I will take the depth as y bar from top. I will take the depth as y bar from top. Okay. This is the neutral axis. Because usually you take y bar from bottom. Today I will take y bar from what? From top. Then here, these 4 bars, see, 4 bars of 16 mm diameter is equal to what is the area of steel? What is the cross? 1 minute. I will put here, no, wait. I will put bars of steel here. 1, little closer I will write. 1, 2, 3, 4. You can see there, you can write there. This is 4 bars of 16 mm diameter. Tell me, what is the distance from here up to here? This distance, how much? What is this distance? That distance, how much? This distance, you know it. 550. This is 550 over. Now, remember now, these are steel. Be careful. To understand better steel, I will use blue color to show that it is steel. Then with a warning, I will use blue color for it. Blue color means, it is not blue. It is actually, once again, same color. 1 minute. Yes. I will use blue color. Blue color means steel. Sorry. Right? Blue is steel. I want to change it to black. To change it to black, black means concrete. Concrete multiply by M. Remember, multiply by M. Right. Now, tell the answer. See, this is nothing. Empty portion. Now, y bar equal to A1 y1 plus A2 y2 divided by A1 plus A2. Yes or no? Y bar equal to A1 y1 plus A2 y2 divided by A1 plus A2. Heard of it or not? Past. Y bar equal to A1 y1 plus A2 y2 divided by A1 plus A2. Tell yes or no? Little fast you have to tell. Yes. Therefore, if I substitute, remember now, any blue color, you have to change it to black color. A1, how much? So your y bar equal to A1, 200 into what? Into y bar by 2, 200 into y bar by 2 plus this area equal to pi by 4 of what? 1 minute now. I will read blue color for it. This area is pi by 4 of 16 square into 4. This is the area of the steel. I have to convert it into equivalent concrete into 13.33 m into 13.33 m multiplied by how much? Tell me. This is the equivalent. Multiplied by A1 y1 plus A2 y2 is 550 divided by what? This area plus this area, 200 into y bar plus pi by 4 of 16 square into 4 into 13.33. Now, tell me, what will happen? This y bar, when this y bar square will come. See, now this is 4. See, when you multiply this way, one y bar square, one more y bar, here y bar square, this will give quadratic equation. Quadratic. Therefore, solving, we get the value of y bar. Y bar will be red color. Why? It is a property of neutral axis. So, right here. Y bar is red color. Solving, you get y bar. Wow. Correct. Daridra. Ivatte barbekamale. Correctly, when I am telling important principle, very powerful principle, rain is completely upsetting me. But is the voice clear? Tell me. If the voice clear, no problem. If the voice clear, okay. Anybody can tell y bar? See, y bar into bracket, this number, take that side, solve and tell y bar. See, form quadratic equation. You write y bar, you take x if you want. X into this number and this number equal to that number. Solve in calculator, equation mode, tell x value. Fast. Rain can't wait for some time because powerful concept is coming now. That moment of inertia concept. Okay. Tell y bar. You how to solve? Use calculator. You write. See, in the calculator, you take y bar as x. Then your equation will become. You take y bar as x. Equation will become what? X into 200 plus x plus pi by 4 of 16 square into 4 into 13.33 equal to 200 by 2 x square plus pi by 4 of 16 square into 4 into 13.33 into 550. Solve the equation, get y bar. Fast. Solve the equation, get y bar. It is a quadratic equation. Right today only this problem, because in the complete BSK class, very crystal clear what? Very important concept. 194.059 or 06. Don't give wrong value. 194.06. Okay. 194.06. 06 millimeter. At least for half an hour if it stops. Okay. Now, this is as per strength of materials. Clear now? Don't worry. Understand the principle. If it takes 2 classes, no problem. Because this is where you learn basics. Over? Clear or not? If it rains, I have to shout. That is a problem. Clear now? Little fast. You are not answering. If you don't answer, I get doubt. Audible or not audible? Is the steps are clear? Okay. Now, see. Or, I will do one more thing now. See. 194. Or, you can do one more thing. What? You write moment of compression area about neutral axis equal to moment of equivalent tension area about neutral axis. Then you easily get, see now, moment of compression area 200 into y bar by 2 equal to what? 200 into y bar into, see, moment about neutral axis. This distance equal to pi by 4 of 16 square into 4 into 13.33 is the equivalent area into 550 minus y bar. Now tell y bar. This is what you are doing in RCC. dx square by 2 equal to m times ast into d minus x. This is what you do in RCC. Solve it. Tell y bar value. If you made any mistake, I can make out now. Getting terribly angry. Right, waiting for this class. Hi. 195.067. It is y bar equal to, you made a mistake there. See, earlier value given by you is slightly wrong. It will come 195.067. Horrible rain. It is horrible rain. Waiting for this class only. You don't know how frustrating it is. How frustrating it is when rain is lashing like anything. No. Is this correct or that correct? Again, see, no answer. I am helpless. Helpless because such a sound cannot be tolerated. No, this is correct. See, because I know this is correct. Anyway, you can tell small error. No. equation? That earlier. No. Once again feed it. Because it is not possible. Okay, check it. I will take 5 minutes break. I cannot talk. Just 5 minutes. Sorry. blasting like anything. I cannot hear my own voice. I do not know how to pause also. Otherwise, I would have paused. Pausing also not possible. I cannot hear anything. getting further worse. Is it correct? This is not required. It is small in front of big. This is like 1 rupee in 1 crore rupee. 1 rupee in 1 crore rupee. You tell it, hey. Correct. Is it correct? Oh, I never. Oh, he started lighting also now. Now, lighting also started. Different answer. No. Correct. Correct actually. I want to explain moment of inertia, but not in this sound. No, this sound, I cannot explain moment of inertia. Not in this sound. already 8:47. Even severe lightning also is there. Helpless in front of nature. So, very horrible. 21. Can we restart tomorrow? You should be here. If you are here, you will run away from here. Anybody here who will run away from here, they will tell, we can't bear this sound. Already 8:48, even severe lightning also. Thunderstorm rain. Non-stop 1 hour rain. Help us. If yes, I will close. I cannot talk. How much I can shout? There is a limit for shouting. Okay. For the nature, helpless people.